Good. So, just a couple of historical notes on what our conception of science has been over the millennia, actually, to give some perspective on its position or kind of how we consider it, and why we consider it authoritative nowadays. So, yeah, originally science was considerably different than what we think of as science now. The word itself just means knowledge. It's a Latin term, actually, but the earliest theories of science, at least properly speaking, would date back to the Greeks. Specifically, I always think Aristotle. Aristotle has the first formulated theory of science and the first kind of definition of science by which scientists themselves kind of identified in various cultural contexts. So remember when we did the syllogism? We did logic, and it had the nice Venn diagrams, and we could verify things with the Venn diagrams. And two premises and a conclusion. That was the syllogism. According to Aristotle, that is science. So that's what he called a demonstration. And what science is demonstrative knowledge. So scientific truth would be the conclusion of a valid syllogism. That's it, right? So, and he defined it in all sorts of other ways. So it can be an a priori one. So in mathematics, for instance, it's knowledge that doesn't really need observation or experience in order to be able to verify that. And they would be called scientists in the one sense because they use scientific knowledge. They're demonstrations, right? Ditto with, or the other kind, what we think of natural knowledge, what we just call science nowadays was a posteriori sciences, or sciences based on observation, according to Aristotle. But again, they all used kind of syllogisms, and that's what made them scientific. Demonstrative reasoning, scientific truths are demonstrated to be true. The other aspect of that too, well, two other things I'll say about Aristotle's notion of science. We do take some things still from it, so it's considerably different, obviously, science according to Aristotle than what we think about it nowadays. But it is similar in certain senses. So, for instance, the distinction amongst sciences themselves, so that different sorts of objects of knowledge are kind of classed as one particular science. So the science of motion of bodies, for instance, physics. Aristotle would have identified that. Indeed, Aristotle's thought of as founding that particular science. Ditto with biology. Biology is a science is thought to going back to Aristotle. It's the study of life. Psychology, the study of the soul, he would have called it. The study of the mind dates back to Aristotle as well. But different propositions under different principles or kind of self-evident truths would follow from that. Different organizations or bodies of knowledge. So that dates back to Aristotle. One thing that's different too, but that carried forward in the history of philosophy or history of science for a very long time, was that the notion, again, science means knowledge, demonstrated knowledge. So it had to be absolutely certain. If you had a demonstrated proposition, demonstrated that it was true, it couldn't be open to probability. It wasn't the case that it might be wrong. No, rather, it was demonstrated to be absolutely the case. In fact, it would be contradictory for you to think of something like probable knowledge. That's considerably different than what we have nowadays, because the reason it's included in this position in the chorus is that science nowadays, anyways, is inductive. And what that means is it's open to probability. Now, the idea, and it dates back to a philosopher named Hume, it's the problem of induction, which I think I mentioned in relation to causality, is, look, we know about kind of the laws of nature, we know about various causal relationships, so fire causing heat or something of the sort, or the two being associated in certain ways, by way of observation. So it's what Hume called the constant conjunction of ideas, what we would just call the steady passage or the repetition of phenomena occurring together, right? So every time I've seen fire, it's been accompanied by heat, right? It's been accompanied by heat, fire, heat, fire, heat, fire, heat. After a repetition of those two phenomena occurring together, we might come to think that there's a causal relationship or something else that's there. And deal with the laws of nature. So we see bodies kind of moving in certain ways, and we posit theories in order to explain their motions in particular ways that coincide or that explain or that kind of mirror those explanations. Now, that's always inductive because, of course, those theories we posit in those causal relationships could always turn out to be wrong. They could always turn out to be wrong. So there could be a third explanation for fire and heat appearing together that we just don't see in there. We discover it and figure out, oh, well, fire is not the cause of heat. And even if we can really say that we've discovered some fundamental kind of aspect of the universe that is essential to the universe, like laws of nature, something of the sort, there's nothing saying that the universe itself can't change at some point. Anyways, point being is that anything based on observation is inductive. And if that's the case, it's probable. It's not absolutely certain. So somebody like Aristotle would say, well, that's not science, because you can't really say that you know it. But yeah, so it just illustrates the difference between the two. And that notion that science is absolutely kind of certain if you have a scientific truth carried right up into the modern period with Hume. I think he's 1700s at some point, Hume. So really, really quite late. And prior to that, it would have been an oxymoron to say that, you have probable knowledge rather than absolute certainty. Whereas nowadays, you're just speaking out of turn. You're speaking unscientific. If you say we've absolutely demonstrated it's got to be the case that this theory is true. Global warming is taking place. We have 100% certainty. Science just doesn't give you to that degree of certainty. No, you have the evidence that suggests the theory is true, but beyond that, no. Anyways, point being, again, science has changed considerably over the years.